Okay, good morning to all of you. In this class, we are going to discuss about exponential distribution. Okay, in our last class, we have been discussed in detail about gamma distribution. This is the PDF of gamma distribution. We discussed about moment generating function of gamma distribution about the origin. Using the moment generating function, we evaluated the first moment and second moment, and using first and second moment we found out the variance. Okay, in our today class we are going to discuss exponential distribution. Okay, so let's start. So this is the definition of exponential distribution, that a random variable x is said to have an exponential distribution or to follow the exponential distribution with parameter theta greater than 0 if its PDF, or that is your probability density function, is given by, that is your fx equal to theta into e to the power minus theta x for x greater than or equal to 0 and 0 otherwise. Okay, this is the definition of the PDF of exponential distribution. Now we have to prove the PDF that this is giving the PDF of the exponential distribution or not. We have to integrate. The limit is 0 to infinity fx dx. 0 to infinity fx means PDF. Here why we taken 0 to infinity? Because the function exists in between 0 to onwards, means 0 to infinity. So here we consider 0 to infinity. So 0 to infinity PDF is your theta into e to the minus theta x into dx. Theta is constant, taken outside. 0 to infinity e to the power minus theta x into dx. So here e to the power minus theta x integration with respect to x will be minus 1 by theta into e to the power minus theta x. So here minus 1 by theta taken outside into e to the power minus theta x, and the limit will be 0 to infinity. Very simple things. So here you can see that theta got cancelled. It will be minus 1, and we have to just put the limits. Upper limit is your infinite, so here it will be e to the power minus infinite minus e to the power 0. So e to the power minus infinite, we know that the value will be 0, and here minus e to the power 0. E to the power 0 is nothing but 1. So here minus 1 will be 1. So hence it has been proved that the PDF whatever defined here is actually accepted for your exponential distribution, right? Now we are going to go for the moment generating function, or MGF, about origin of exponential distribution. In general, MGF about origin is written as mxt is equal to expectation of e to the power tx is equal to minus infinity to plus infinity into e to the power tx into PDF into dx. So for continuous distribution we have to consider PDF, and for discrete it will be PMF, that we know, and the integration will be considered as summation, that we know very well. So here in general MGF about origin will be this much. For this case mxt will be mxt equal to 0 to infinity e to the power tx into theta into e to the power minus theta x into dx. So here e to the power tx into PDF for this case is nothing but theta into e to the minus theta x, whatever this one here I have been substituted into dx. Okay, so here why 0 to infinity? Because PDF has been exist in between 0 to onwards, means 0 to infinite, and less than infinite the PDF does not exist. So here you can write this statement. Here I not written one step, that 0 minus infinity to infinity e to the power tx into fx dx minus infinity to 0 e to the power tx into fx dx plus 0 to infinity e to the power tx into fx dx. However, fx probability density function for this exponential distribution is 0 in between minus infinity to 0. So this entire term will be 0. So hence we are going to get 0 to infinity e to the tx fx dx. So this line step, or you can say step, here I not written, may you can write in a note here. Okay, now you can see that theta is constant taken outside. Here this two powers is going to be add up, so it will be e to the power minus theta minus t into x into dx. Now we are going to integrate this one with respect to x. It will be theta is here, so integration of this one will be how much? 1 by minus this one. Okay, 1 by minus theta minus t e to the power theta minus t into x 0 to infinity. It is very easy. See, e to the power x is nothing but integration of e to the x is nothing but a into e to the x. So here instead of a we have to write down how much? Minus theta minus t. So here minus theta minus t e to the minus theta minus t into x 0 to infinity is the limit. We have to put infinite over here. This will be e to the power minus infinity minus 0 we have to put, it will be e to the 0, and here theta by minus theta minus t is nothing but your minus theta by theta minus t, right? E to the minus infinity minus e to the 0. We know that e to the minus infinity value is nothing but equal to 0. So here we found minus theta by theta minus t into this will be e to the 0 is nothing but 1, so minus 1. So minus minus multiplied and we are going to get theta by theta minus t, or you can get that if we are going to divide theta with each term, you can get 1 by 1 minus t by theta. Okay, so that implies mxt is equal to 1 minus t by theta to the power 1 by 2. If I will expand this one, we can find that 1 plus t by theta, this is the common expansion. Okay, this is the common expansion of 1 by 1 minus x is nothing but 1 plus x square plus x cube, like this. So here instead of x we have how much? 1 by 1 minus theta by t, right? Or we have 1 minus theta by t to the power 1 by 2, right? 1 minus theta by 2 to the power 1 by 2, or this is nothing but 1 minus theta t by 1 minus t by theta, that is nothing but 1 minus t by theta to the power minus 1, whatever written over here. So if I am going to expand these things, this one, then we are going to get 1 plus t by theta plus t square by theta square plus so on t to the power r by theta to the power r plus so on. Or in summation format we can write this expansion as mxt equal to summation over r equal to 0 to infinite t by theta to the power r. So if you have put r equal to 0, you are going to get 1, put 1 t by theta, put r equal to 2 t square by theta square. Okay, so anyone you can use for your any purposes to solve the problems. You can use this one, and or you can use this one, same thing. Okay, so now we are going to go for the moments about origin, and using the moments mean and variance we are going to find out. Here we are going to find out the two moments, first moment and second moment about the origin. Okay, if you want you can evaluate the higher order moments. So here we know that rth moment about the origin is rth derivative of moment generating function, right? This is your moment generating function. It is written as moment generating mxt. This is your mxt, which is differentiated with respect to t r times. Then you have to put t equal to 0. you are going to get the rth moment, which is represented as mu r dash, right? This is known to us very well, right? Now first moment, we have to consider the first moment, that r equal to 1, that means mu 1 dash or expectation of x will be how much? Mu 1 dash, that means d by dt of this series format of mxt we have been considered here, that is your this one 1 plus t by theta plus t square by theta square. This one I have been considered here. Okay, so here d by dt of this one 1 plus t by theta plus t square by theta square plus t cube by theta cube and so on, t r by theta r. Now we have to consider the first derivative with respect to t. This is 1, then the value will be 0. 0 plus 1 t by theta differentiate with t, so it will be 1 by theta, t square by theta square, it will be 2t by theta square, because theta is constant for derivative with respect to t. Okay, then this will be 3t square by theta cube and so on. And if we are going to consider this term derivative with respect to t, it will be r into t to the r minus 1 by theta to the power r and so on t equal to 0. You can see that except this term, all the terms have the t. So whenever we are going to put t equal to 0, except this term, all the terms is going to be cancelled out. So we found mu 1 dash equal to 1 by theta, which is nothing but your expectation of x or mean. Okay, now we are going to go for the second moment, that is your mu 2 dash or ex square. That means second order derivative of moment generating function with respect to t. Mu 2 dash will be equal to d square mxt by dt square at t equal to 0. So d by dt of first derivative, you can say the first derivative already we found this much, right? I just substituted this one. So d by dt of this one, this is represent the first derivative of mxt, whatever we have here. Okay, this one I substituted over here, d by dt of this one 1 by theta plus 2 t by theta square and so on. So now we have to consider d by dt of this one, then here this is constant, differentiation with respect to t will be 0 plus this is your 2 into 1, because with respect to t if you are differentiate then it will be 1. So 2 into 1 by theta square plus this will be 3 into 2 into t by theta cube and so on. So this term will be differentiate with respect to t, then we can found r into r minus 1. Here power is r minus 1, so r into r minus 1 into t to the power r minus 2 by theta to the power r plus so on. Theta equal t equal to 0 we have to put now. Here you can see that except this term, all the terms contains t. Okay, so now if all the terms have t, so now if we are going to put the t equal to 0, then except this, all the terms are going to be cancelled out, right? So now we are going to find out mu 2 dash equal to 2 factorial. You can see 2 into 1 can be written as 2 factorial by theta square. This is your second moment, right? Or this 2 factorial is nothing but 2 by theta square. Now variance. What will be the variance? You can see variance is nothing but second moment minus square of the first moment, or ex square minus ex whole square. We found ex square or second moment is nothing but your 2 by theta square minus your first moment is your 1 by theta. You just put over here 1 by theta square, that will be 1 by theta square, and we found variance is your 1 by theta square. So this is the variance 1 by theta square, and the mean of the exponential distribution is your 1 by theta. Okay, see in our last class also I told, this class also I am telling to you that these moments also can be evaluated by this way. that is your expectation of x is nothing but is your mu 1 dash, right? That is nothing but 0 to infinity x into this is your pdf into dx. You just do it in this way that you are going to get the same answer, right? See, theta is constant taken outside, 0 to infinity x into e to the power minus theta x dx. Now just consider the islet and solve this, do this integration. This is the first function, second function. So first function will be here, the integration of the second function, this will nothing but 1 by minus theta into e to the minus theta x 0 to infinity, and then minus derivative of x, derivative of first function, that will be 1, and integration of this one e to the minus theta x will be nothing but this will be 1 by minus theta into e to the minus theta x into dx. Again integration we have to consider. So here you can see, if I will be put limit infinite, then here you can see e to the power minus infinite is 0. So 0, and if I am going to put 0 again limit, then x is here, so 0, this term is going to be 0. Now here you can see that this is minus minus plus, so here you can see that here I mistakenly written this is theta, but actually this is 1 by theta, right? Okay, no problem. So here is minus 1 by theta minus, so plus 1 by theta. Again we have to consider integration of e to the power minus theta x, that will be 1 by minus theta e to the power minus theta x 0 to infinity. You just put limit infinite, this will be 0, then minus of e to the power 0 will be minus 1, right? So we are going to get this will be how much? See, this is 1 by theta into 1 by theta, here 1 theta is there, so theta theta got cancelled, we found 1 by theta. Okay, if we are going to put infinite, so it will be how much? E to the power infinite will be 0 minus e to the power 0, e to the power 0 will be 1. Okay, e to the power 0 will be 1. So here it is written, here I am written, okay, you can see that here I have written, you just see 1 by theta minus theta, so it will be minus 1 theta, theta got cancelled, so it will be 1 by theta, so minus is here, e to the power minus theta x 0 to infinity, just put the limit, minus e to the minus infinity plus e to the power, see it will be minus of e to the 0, already minus is there, so plus e to the power 0, simple things, so it will be 0, so we are going to get how much? 1 by theta. Okay, 1 by theta exactly matched whatever we done in this way, right? Similarly, x square also you can found in this way, that 0 to infinity x square into theta into e to the minus theta x into dx. This is your pdf, theta taken outside, x square e to the minus theta x dx. Here we are going to consider Kronecker method, or you can consider 2 times integration by parts, no problem. See, here we consider the by parts. Okay, here you can consider 2 times by parts, no problem. Here I used Kronecker method. Kronecker method means gx phi x dx. If integration we have, then it will be then it will be gx integration of phi x dx minus, second term will be minus derivative of gx, and double integration of phi x, then plus, third term will be plus second derivative of gx and third time integration of phi x, and then minus, and so on, right? Up to gx we are not going to get 0, so whenever we are going to get gx, here we are considering gx g dash x, g double dash x, so likewise if you are going to do, then at a particular term you are going to get g this term g some nth derivative will be 0. Okay, up to that we are going to consider, but here up to g double dash x is enough for us here. So the first term will be gx, means here instead of gx we have x square, right? Instead of 5x we have e to the power minus theta x, and here theta is there taken outside. So gx and integration of 5x means e to the power minus theta x, integration is nothing but minus 1 by theta e to the power minus theta x, limit 0 to infinity, right? Minus derivative, first derivative of gx minus 2x into again second derivative of this one. Okay, already first second integration of this one, second integration of 5x, but first integration of 5x answer is this one. Then I have to consider the second integration of this one will be, it will give this one. See, first integration of 5x is nothing but this one. Okay, then if I am going to consider integration of this one is nothing but second integration of 5x, right? So if I am going to consider the integration of this one, how much I can get? Already 1 by theta is there, minus 1 by theta, minus 1 by theta is there, then e to the power minus theta x integration is minus 1 by theta into e to the power minus theta x 0 to infinity, right? Then plus derivative of double derivative of gx. Double derivative of gx means first derivative is your 2x, second time is your 2, and then triple time integration of 5x. Double time integration of 5x is nothing but this one. Again I am going to consider the integration, that means minus 1 by theta, already minus 1 by theta, minus 1 by theta is there, minus 1 by theta, minus 1 by theta into again integration means minus 1 by theta into e to the minus theta x, 0 to infinity, right? So here you can see that if I am going to put infinity is the limit, then e to the minus infinity will 0, 0 I will be put, it will be 0, so this term will be 0, likewise this term also will be 0. Now you consider this term, 2 is there, 2 minus minus minus, so minus 1 by theta cube, okay, into e to the minus theta x 0 to infinity, put infinite, it will be 0, minus 0 e to the power 0 will be 1, so minus 1, here is the minus, so we are going to get plus, so plus 2 into 1 by theta cube, that will be nothing but 2 by theta square, which is exactly match with your this answer. Okay, 2 by theta square. Okay, so I suggest that in your note you have to write down in this format. By using moment generating function you found moment, first moment and second moment, and do these things in your rough for your practice. Okay, watch carefully this video, write down the note because note is very much essential for your exam point of view, and ready for the next class that we are going to discuss about beta distribution. This is another continuous distribution. Okay, beta distribution. So thank you so much for watching this video. Thank you.